Today I'll talk about a very important, recently evolved concept about the usage of not just PLS-SEM but combining PLS-SEM with fsQCA along with NCA and also moving over to IPMA, which is Importance Performance Map Analysis, and also involving necessary configurational analysis, which is a recently evolved technique. So this video is going to be quite important for all those who want to write in a meaningful, technically advanced research article using all of these different techniques which I mentioned right now. So stay tuned and just watch it carefully. Now, let us start with PLS-SEM. We all are aware of the work which we can do using SmartPLS. Variance-based structural equation modeling can be done in SmartPLS. Whether you have SmartPLS version 3 or SmartPLS version 4, you can easily do variance-based structural equation modeling. PLS-SEM is not restricted by the sample size and normality of the data. So it is much flexible as compared to regular structural equation modeling, which is covariance based structural equation modeling done previously using AMOS, analysis of movement structures. IBM SPSS AMOS software was used. These days SmartPLS 4 has integrated CB-SEM as well. So you can do PLS-SEM as well as CB-SEM in just one software, which is SmartPLS 4. Now, let us move over. The first step is measurement model assessment in a structural equation modeling. So once you have assessed the factor loadings, in case you have reflective indicators, you have assessed the outer weights in case you have formative indicators. Then you check the reliability and validity to establish that the survey questionnaire is reliable and valid to be taken ahead. This is known as measurement model assessment or outer model assessment. Now, the second step is structural equation modeling, where we strive to find out the relationship, the path coefficients between our independent and dependent variables in the conceptualized model. So if the path coefficient is significant, we say that yes, it exhibits a significant relationship. There is a strong relationship between independent and dependent variable. But one thing to be noted over here is that we are able to assess the relationship individually for each latent variable, which is an independent latent variable, towards the dependent latent variable. We are not able to assess the combined effect of all the independent latent variables on the outcome or the dependent variable. So this is known as symmetrical analysis. Now, fsQCA, which is fuzzy set qualitative comparative analysis, helps us to resolve this issue, wherein we can see the effect of the combined effect of these independent latent variables on the outcome variable. Which of these are necessary? Which of these are sufficient to get the outcome? This is what we do through fsQCA, which is a separate software in itself, developed by Professor Charles Ragan. Now, recently, the researchers have evolved the technique which is known as Importance Performance Map Analysis, IPMA. Now, in which we assess the important factors and the performing factors as well for getting the outcome. So which are the independent latent variables which are important and which are the ones which are performing well to get the desired outcome level? This is known as IPMA. Now, next, if we have done the measurement model assessment in SmartPLS 4 itself or SmartPLS 3 also, we can easily do IPMA. We take in these rescaled latent variable scores from IPMA to do NCA, necessary condition analysis. So, which are the conditions which are necessary to achieve the outcome, without which we cannot get the outcome? Now, this same thing can be done in fsQCA as well, but that gives the necessary conditions in kind, not degree. But necessary condition analysis, which is a technique in itself, can be done in SmartPLS 4. But if you don't have SmartPLS 4, you can do necessary condition analysis following a simple command in RStudio also. So you can take those rescaled variable scores for doing necessary condition analysis, and now you have identified the necessary conditions. What next? After this, there is one issue which is arisen. You are able to find the necessary conditions to achieve the outcome, but not the necessary configurations which are more meaningful. This is known as NConfA, necessary configurational analysis. So necessary configurations analysis is something which you do on the basis of sufficiency analysis which you have done in fsQCA. So in fsQCA, you get sufficient conditions. In those sufficient conditions, if you get combination of conditions which are occurring more than 50% of the times in the available sufficient configurations, the sufficient configurations which you have gotten through fsQCA, say you got 4 different configurations to achieve the outcome, sufficient configurations. Now, the combination of 2 or more latent variables which is same across these 4 and is occurring at least in 2 of these configurations, that is 50% at least, you take those configurations, you combine them into a single score. Herein, you again take these scores to NCA and you develop a bottleneck table. Herein, you are able to identify those configurations which are essential to achieve the outcome. Not just the necessary conditions, but necessary configurations. In case you don't want to do IPMA, then straight away from measurement model assessment, once you have done the measurement model assessment in SmartPLS, you can take in the unstandardized latent variable scores into NCA for doing necessary condition analysis. Unstandardized latent variable scores. Remember that. In case you want to do fsQCA, taking the latent variable scores from measurement model assessment of SmartPLS, then you take the standardized latent variable scores for calibration into fsQCA. How are these to be calibrated? Recent articles have mentioned that you can take -3, 0 and +3 as minimum, crossover and maximum point threshold for calibration of standardized latent variable scores which you have taken in from measurement model assessment of SmartPLS. That is how you can do fsQCA. So now you see that all these different techniques come together to give you a more meaningful and robust solution in terms of behavioral aspects of the people, which is quite important in social science studies. Not many papers, not many articles have been developed upon the combination of all these, but if you do write a paper on the combination, using the combinations of all these different techniques, understanding them well and then using them, you can get an article which is more technical, more meaningful, and is there to be selected by good journals for the publications. In upcoming videos, I'll show you how to do this, how to do all this. I'll show you a demo in R software as well, RStudio. In case you don't have SmartPLS 4, no need to worry. If you do have SmartPLS 4, it becomes quite easy because you can easily do IPMA and NCA in SmartPLS 4 itself. Otherwise, for NCA, you will have to move into R software, RStudio, put a command, learn how to put in commands and get the results thereof. So see you next time with some more informative video. I hope this short video was quite informative and useful for you. Do share it with your friends and faculty colleagues. Thanks a lot.